Hi everybody, today we learned how to solve two different types of equations. One type is when you have a radical in the equation, and the other type is when you have a rational or a fraction exponent. And this first example is one where we've got a radical in our equation. And so the first thing we want to do is move this 5 out of the way. Remember, we're trying to get x by itself. So that leaves us with negative 4th root of x equals negative 5. We're going to divide both sides by a negative 1 to get that to be positive 4th root of x equals positive 5. And then this is what we'll learn today. In order to cancel a radical, we use an exponent. So I'm going to put both sides to that 4th power. The 4th power cancels the 4th root, and we'll get x equals, you would punch this into Desmos, 5 to the 4th power is 625. Okay? Over here, I want you to notice that we have not one, but two radicals in our equation. It's really important to notice that they're on either sides of the equal sign, so the equal sign's in the middle. To cancel that third root, we're going to give both sides the third power, which leaves you with x squared plus x minus 14 is equal to x plus 50. Notice this is a quadratic that we're going to be solving, and so we have to get it set equal to 0 in order to solve. So I move these two things over to the left-hand side to do so. That leaves me with x squared. The positive and negative x's cancel, so we've got minus 64, and then we've got that 0 on the other side. Now I want you to notice that we canceled that middle x, so to solve this one, we're going to add 64 to both sides. And we'll see that x squared is equal to 64. So then we can square root and get x equals plus or minus 8. 8 squared is 64, so the square root is 8. Then we need that plus or minus because anytime we take an even root in order to solve, we include a plus or minus in our answer. Okay, now this will be the other type. So for this equation, we're solving where we've got a fraction or rational exponent. Your first step is always to get rid of that multiplier that's out front, if you've got one. So we're going to divide both sides by 3. That'll give us 81. Then the trick to get rid of that rational exponent is to give both sides a power of the reciprocal, so 3 over 4th power. Okay, these guys will cancel each other out, and so that leaves us just with x. And then 81 to the 3/4 power is 27. Desmos would help us with that. And then notice, remember we have exponent over root, so that's our root, and it is even, so we need a plus or a minus in front of our answer. Okay, now this one will do the exact same thing. We divide away that 2. So we'll have x to the 1/4 power equals 4. Then we take the reciprocal, so 4 over 1, which will simplify. This is x. 4 to the 4th power is 256. All right, now to do number 5, we're back to a radical equation. So we'll add 4. We move that extra term over to the other side. So then we have the square root of 2x plus 8 is equal to 10. Now we'll square both sides and get 2x plus 8 is 100. When we subtract 8 from both sides, we get 2x is equal to 92. And divide by 2 to get x is 46. Okay. Now remember up here on number 2, I said it's really important if we have two radicals to have one on each side of the equal sign. So down here, we're going to add this 2 radical x to both sides so that we have the square root of 12 minus 2x equals 2 times the square root of x. Doing that allows us to square both sides, which will cancel our radicals. but also square this coefficient, so that'll be a 4 times x. 2 was being multiplied by the square root of x, so now our 4 will be multiplied still by x. To combine like terms, I'll add this 2x, and we'll have 12 equals 6x. If we divide by 6, we'll get x is 2. Okay, over here we're going to add 2 to both sides. We'll have the cube root of x squared plus 4 is equal to 2. Now because that's a cube root, I'll give it the third power to cancel, which gets me x squared plus 4 is equal to 8. Then we'll subtract 4 to get x squared is equal to 4. And now because that x is being squared, we'll square root to get x equals plus or minus, it's an even root, 2. Okay, now over here, notice this guy has a square root, so to cancel that, we're going to square both sides. Now when we square this side, we're squaring that whole x minus 3, which means we're basically going to multiply it by itself. Okay, and when we multiply it by itself, we're going to distribute. So we'll give the x to the x and to the negative 3. Then we'll give the negative 3 to the x and to the negative 3, which gets us x squared minus 3x plus 9 is equal to 4x. Well, this simplifies to be negative 6x plus 9. And then remember, it's a quadratic. X is being squared, and so to solve, we have to set it equal to 0. So x squared minus 10x plus 9 will be 0. Now, in order to solve a quadratic, we use either factoring or the quadratic formula, especially when we've got this middle term like that. And this one is factorable, right? We know our first terms have to be x in order to multiply to get to x squared. And then our last terms are going to be 1 and 9 in order to multiply to 9. So that they add to negative 10, they'll both be negative. Okay, now we set those equal to 0 in order to solve. So x is 1. Oops. And x is 9. All right, now over here, you might have guessed that we should add that 3. So we'll have 8 minus 2x raised to the 5/4 is equal to 32. Now we'll use that scale again. We'll flip that exponent and say 4/5 on both sides. So now we'll have 8 minus 2x equals 16. When I subtract that 8 to move it over, I'll have negative 2x equals 8. And when I divide by negative 2, x will be negative 4. All right, now last but not least, this guy has a negative out in front. Imagine that that's basically a negative 1. And so we're going to divide that away. So we'll have x to the 3/2 equals 27. Then we'll flip that fraction, give both sides the 2/3 power, which gives me x equals 9. Okay, again, Desmos would do all that math for you if you didn't feel like you could do it in your head. Okay, see if that helps you do your practice, your exit ticket, and hope to see you tomorrow.